So a little bit of a demo. So some disclaimers before I get started with the demonstration is I can't show you everything that I've done because it takes hours of time to actually do it all. But what I'm going to show you here today is the output of what we've done. It's our hope that we can then scale down this workflow and then we can make it much more sustainable, and then we can start sharing it across our community as well. So I'm just going to share my screen, bring everyone back up, and then I'll talk you through what we've got on the screen. So on screen, we have, Sharon, your hand is up. No, it's not anymore. No problem. It was still lingering on mine. So on screen, we have a PDF file for, which contains some traditional sort of STEM content. We've got titles. We have some nice STEM content. So we've got some inline math. We've got some heading styles. We've got hyperlinks as well. And as we come on down, we've got images, we've got tables, and we've also got some charts as well. Now, all of this PDF has been compiled straight from LaTeX, so using Overleaf is what we use to compile it. And it's not had any post-remediation whatsoever. So this is straight out of how it comes out from PDF, from Overleaf. The big thing, the big win that we've had recently is we've managed to be able to compile something which actually has some kind of heading styles, which is really nice. So first things first, we've got headers. So for 90% of students, that's going to make the file much easier to actually navigate, particularly if it is a long file. We know we support academics who tend to put the course workbooks together rather than doing the individual problem sheet way. So next up, we have this paragraph text here. And you'll notice straight away, it's all paragraph text, which is, it's not so good. What that means is that a screen reader will try and interpret all of this, but it won't give any of that semantic information or the presentation information to these maths equations. So what I'm going to do is I'm just going to very quickly open up another version of this file. Downloads, this one. Is it? Definitely in here. Is this the one? Yeah, this is very similar. So it's very similar. And the first thing you'll notice from the tagging trees is it's a lot cleaner. There's some hierarchy in here. I've got some sections. I've still got my headings. So I've still got my header ones. If I come down to this one.
To confirm, this is generated from Overleaf?
Yeah, straight out of Overleaf, again, with no post-remediation. So this is just what we've managed to get with the right combination or concoction.
This is amazing. This is amazing.
We're quite happy with the results so far. But what we have now is we have our paragraphs, which are going to be combined as parts. We have it tagged as a paragraph text, but contained within that, we have the actual paragraph containers, and then our math formulas are being contained as math. Now, what this means is if I come to properties of this tag, the actual text is what is read out to somebody using a screen reader straight off the bat. So we have a PDF which has heading structures, alt text, descriptive hyperlinks, as well as having some tagging, which is reasonably accurate. The maths is pretty good. However, in my mind, there is a caveat that your reader needs to really understand LaTeX to understand what is being read aloud to them. So we went further with it. We thought, let's have another win. So using Pandoc, working together with some of our software engineers within our team, we managed to build a web interface for Pandoc. It's currently hosted on a local server, so I can't share that with you today, but I can show you some of the outputs that we have from that. So using Pandoc, we immediately were able to convert it to a HTML file. All of the math is then rendered using MathJax. I'm sure there's some big fans of MathJax in the room. We've got our heading styles. We've still got our images, we can come to inspect, and it all retains all the alt attributes as well. We have our tables, and the tables have been semantically tagged properly as well. So we've got table headers, table rows, which is quite nice. And our hyperlinks still work too. So that was really, really cool. So off the bat, we've got something that works quite well. However, Blackboard Ultra doesn't support HTML files really well. It kind of renders them quite poorly. So we had a quick play at what other file formats might this come to. So we had a go with a Word file. And again, this is with no remediation afterwards. We've managed to get our Word file in here. The only thing that is not pulled through is heading styles. But given how accurate or how quickly you can apply a heading style in Microsoft Word, it shouldn't be too much to actually change that. So what we've got is we've got all of the equations are then rendered with the Office equation editor. We have our image down here, which still should retain its alternative descriptions. We've got our hyperlink back up here, which still has still a hyperlink. We can still get to the right place, which is pretty neat. And our table as well. If I'm correct, it should have a heading row denoted, repeat header rows. Wait. It's just that one. There we go. Yes, and it's got a header row as well. So without any more remediation, this has worked really well. There are some caveats with this. We got really excited really quickly, and we were like, what's the scale of this? Does this work for everything? And the answer is, of course not. Nothing in the world would be that good. But it means we tried it with some larger tech files, things with like custom macros, much more niche LaTeX packages, things you won't find on CTAN, and some custom things like that. And it didn't work all that well. Once there was more in the file for it to process, it got confused and it would start tagging things in a rogue kind of way. So now instead what we've got is we've got a way that we can publish more accessible worksheets as long as they are kept simple. And I think that's my big takeaway from this process is this only works if you keep things simple, which in the world of STEM accessibility, I know it's difficult, but it's something we're all striving for, isn't it, really? If we can keep it simple, then we can train as many people as possible to make progress in this area. Cool.
Thank you, Luke. I think we've got 2 questions. Does Charlotte want to go first?
Yeah.
Yes, thank you. Just coming back on the Blackboard Ultra support of HTML, is that when with like just adding content and just pasting HTML? Because what we've tried with the Chiron output is basically uploading the entire site, just a set of HTML pages, as a folder in the content collection, and then sticking the index.html as like, basically a file.
Okay.
And then that literally works perfectly because it just, opens in a new window, and that's your whole HTML site with all bells and whistles.
Oh wow! Does it present quite well, or is it like responsive as well?
Exactly as you have it.
Because
it gets out of Blackboard essentially.
Oh, amazing!
But then it retains all the sort of authentication and permissions.
I might be able to demo that for you if you give me 30 seconds.
Yes, please. This is
Can I just say that workflow may only work for those of us who have the right permissions on Blackboard. So not every tutor. So Alexandra, who's on the call, will know we had to set her permission so she could upload files to the content collection and have the MathJack script, basically the scripting run, and the students can see it. But not every lecturer has had that enabled for them. I don't know if it's true in your organizations.
From what we've tried on kind of various playground courses where we might have basically more permissions, that seems to work fine. But that's definitely, if it's a solution that works fine, then my next move would be to lobby very hard with the learning technologists to have that available widely. Can I ask just another question related to the the last bit you said about keeping LaTeX simple. That's also been basically our main concern throughout this project we're doing here. We sort of wanted to find a method that required the least amount of changing existing source files as possible, because we really want people to actually engage with this. So we kind of went the other way and tried to find a solution that was as compatible as possible with people's, massive style files and preambles and that, of course. One thing I wanted to look into, and I wonder if anyone knows about this, is there a way for when compiling some output from a tech file, presumably at some point the macros and commands and things get expanded. I'm wondering if there's a way to capture that step of the output, because at that point, it's going to be a very unwieldy piece of tech markup, but with no macros and substitutions and custom commands. I wonder if that would kind of play more nicely.
Yeah, that's a really good question. I think from the top of my head, so we've used Pandoc for these file conversions here. Pandoc will expand the outputs of your own declarations, but it won't keep that expanded. It will then substitute it back down for the output file. And I don't know if there is a way to almost put like a flag halfway through to say keep this expanded so we can see what's actually going on, because I'm always a bit unsure as to what's been processed as a macro and what's actually just been passed over. I'll make a note. That's a really, really good question. Thank you.
Vincenzo, do you have your hand up?
Yes, yes. I wanted to make one thing would be for just look. Can you show us what code did you use to let Overleaf make these documents first? I think it's going to be one line at the top, but I would like to, I think it would be nice to see it, because it should be simple. But of course, the other thing I want to say two things that I've written in the chat already. One is PDF tagging is still extremely experimental, and I would recommend against using it in production, because it relies on your screen, your PDF reader actually understanding it, and Acrobat itself doesn't understand all of the nuances of the PDF tagging as is done by PDF LaTeX now, because PDF LaTeX is using the new standard 2.0 PDF. Screen readers don't understand it. That's a point you made already. And of course, the final thing is HTML is way more functional for accessibility. So I want to advocate for that.
Absolutely.
So I just wanted to say this because I've seen people jumping on accessibility packages in the last few years, and they keep saying, "Oh, you should use the accessibility package," and even those packages tell you, "Don't use me."
Yeah.
And yet people jump on it. So I just wanted to sort of say this is super cool, but it's going to be maybe one or two. I don't know if you're in touch with the developers who are doing this work. How much you know with that. So sorry for I'm kind of ruining the thing.
No,
so,
no. You bring up very valuable points.
But the second conversion from the PDF to something else, that was impressive though.
Yeah. I think the reason, so we were discussing it right at the very start of the meeting, the reason why I think so many of us still default to PDF over HTML is simply because of the usability rather than the accessibility. Students will want a file which they can draw over the top of, it replicates that pen and paper in a digital format, whereas HTML, for the life of me, it just hasn't captured like a digital whiteboarding sense in any way. And I always get a bit frustrated with digital whiteboarding and like online drawing and all of that, because it should be so good by now. It should be, but it's so poor in terms of even like handwriting recognition. only now are we getting to a point where we can get a reasonable kind of output from some handwriting, even on simple one-page pieces of math. Absolutely. David, your hand is up.
See if I'm too loud in the background. Yeah, this is why kind of in stuff I've been doing, I'm very much kind of trying to create both HTML and PDF. So using like Quarto, so that I can, my target is HTML really, but I work hard to make sure that the PDF that comes out, the one is compiled by LaTeX in the background, still works nicely.
Yeah.
Because there isn't an answer yet to like annotations on HTML. Doesn't exist yet really nicely.
Yeah, no, that's a really good point, and I think that's. I don't think Christian's not here today, doesn't it like? But that's also one of the big benefits of Chiron, is you get both of those file versions.
The other issue is that people are talking about the issues of uploading HTMLs to different blackboards and canvas and stuff like that. The other issue there is that, like, if you can try and make one HTML with all the content hidden inside it to try and get around some of the issues, but then you're talking about a massive file. So ordinarily you want to upload a whole directory full of sub-files, but it becomes some of the permissions nightmare. It can be. I've never had a problem getting it to work, but it's temperamental in both Moodle and in Blackboard.
Yes, I know from my own personal experience, one thing that took me maybe, well, I can say I'm amongst friends. It took me about 2 weeks to work out how to actually convert the file in an automatic sense to base64 to have it embedded as a standalone HTML file. It took me an embarrassing amount of time to wrap my head around what was trying to happen at that point, but we did manage it in the end. Yes, David, your hand's up again. Awesome. Okay. So what I'm going to do is, I don't have the LaTeX compilation on this device, but it's on my workstation. So tomorrow, it's Monday today, tomorrow afternoon around 1 o'clock, I will send an update via the mailing list of the little snippet of what we've included in the HTML, in the LaTeX, so you can all have a test in your own Overleaf packages as well.